Okay, so for part 2 we left off here, or part 1 we left off here. We're starting here for part 2, and we're going to use our knowledge of these exponents to help us figure out these answers here. So A, for y equals x squared, find y if x is -2. Okay, so they're telling us right now that x equals -2. We're just going to plug that in here and figure out y. So really we have y equals -2 to the second power. So we just took this and we plugged it in for x there. Okay? So y equals -2. Well, 2 to the second power is 4, and this is even, so we should get a positive answer. So this should be 4. If you would have wrote that out the long way, it would have been -2 times -2, and 2 negatives multiplied together gives you positive. That's where we get 4 from. Now they're going to make us think about this backwards now. If x squared equals 9, then x can be which two numbers? So basically, what we've done in the past, and saw like things like Pythagorean theorem, if we've gotten to this point, to solve for x, we would take the square root of each side, and that would give us x. And square root of 9 is 3. And the reason that this works is because 3 to the second power it gives you 9. Okay? So yes, that's okay. We can do that still. But what we need to know now that we know things about our integers, we know that 2 negatives can multiply to give us a positive. So can't x also be -3? Yes, it can, because 3 times 3 gives us 9, but so does -3. That also gives us 9. So x can be +3, it can also be -3. So now when we take square roots and things like that, when solving for a variable, we need to make sure that we're aware that we could get a +3 and a -3, or a positive and a negative of that number. Sometimes the negative number won't apply. Let's say we were talking about distance, and maybe x was a distance. You could be aware that we could get a -3 or a negative answer, but a negative distance doesn't really mean anything, so then you would use the positive one. Okay? So we just need to know that we can get both of those answers, and if it applies, we would want to list both of them. Okay? And one way to do that, that you will see in high school, is they may write it like this: x equals ±3. So ±3, you could list both of them like I did before. You could say x equals -3 and 3, doesn't matter to me. This is just the shortcut notation: x equals positive or -3. Okay? Alright. So this kind of shows you what I took us through before. So we distinguish between the word square root and the radical. So we call it the radical or the square root. So the radical indicates the principal square root, which is the positive square root of a positive real number. So the ones that we usually talk about are the principal square roots. But the square roots of 9 are 3 and -3. Okay? Now if we take the radical of 9, or we talk about just the principal square root, we're just talking about the positive one. That's not going to be such an issue. So if we talk about, well, they'll point this out, but you're going to know, like I said earlier, when they need to talk about the positive and the negative, or if they just want the positive, that will be pointed out to you. So principal square root, though, that means the positive square root of a positive real number. Okay? Not a huge deal. But just another side note here: if you use a calculator with negative numbers someday, which some of you already do, you need to be careful how you enter your data, That's why being able to do things by hand is important. I get a lot of students that try to type things all at once, and the calculator doesn't like it, and it comes out with an answer that the student doesn't like. You have to know how to type those things incorrectly too, okay? So knowing how to do something by hand is very important. Alright, so now into the algebraic terms part of this. We can apply what we've learned so far today to algebraic terms. And we're going to use the stuff from today as well as previous lessons, such as our laws of exponents. Now, this looks a little messy, but we are going to simplify. Remember when we combined like terms, we would add them. Now we are multiplying and dividing terms. They do not need to be like to do this, because remember, with our laws of exponents, as long as something has the same base, we can add or subtract our exponents depending on whether we're multiplying or dividing. So for instance, x to the a times x to the b, that equals x to the a plus b. That's one of our laws. So if we look at this, everything is being multiplied. First, let's multiply our numbers together. We have 6 times negative 2. And 6 times 2 is 12. And we have a positive times a negative, different signs. We get a negative 12. Then let's look at things that have the same base. X squared and x. So we have x to the second times x to the first. If we don't see a number there, then it's a 1. Now we can use our rule. If they have the same base, we can add the exponents together, a plus b. Well, here our a is 2, our b is 1. 2 plus 1 is 3, x to the third. So we have x to negative 12 times x to the third. Now let's look at our y's. We've got a y and a y. And they both have 1s there because there's nothing there. So same base, y and y. Exponent is 1 and 1. We add those together, we get 2. And z doesn't have anything that we can multiply it by, so it just hangs off by the side. So this would be our answer, a simplified version of this. So this originally said 6x squared y times negative 2xyz. Now we've simplified that to negative 12 times x to the third times y to the second times z. Or 12x cubed y squared z. Okay? It sounds like and looks like a mess, but eventually what we'll be able to do is multiply terms and then see if we can't combine them with other like terms that are with those. And this is just the very beginning of all of this. Okay, our division exponent law said if we had x to the b over x to the a, we could go b minus a. Alright? So the top one minus the bottom, if we have the same base. So we're going to do the same thing again. We're going to look at our numbers first of all. We're dividing now. 6 divided by negative 2 is a positive 6 divided by a negative. We're going to get a negative answer. 6 divided by 2, negative 3. Okay? Let's look at our x's there. We have an x squared over an x. 2 minus 1 is 1. So x to the first, or just x. I'm going to leave it as just x. Our y's, we have a y to the first and a y to the first. 1 minus 1 is 0, and y to the 0 power is 1. Anything to the 0 power is 1. So these just cancel out with each other. They're gone. There's no y's. And then we also have a z, but there's nothing on top to cancel it out. So z stays in the bottom, and we're left with negative 3x over z, just like that. Now one way we could have done this, otherwise real quick, we could have listed everything out. 6x xy all over negative 2xy z. You can cancel out one x and some y's, and you're left with divide here, 6 divided by negative 2, negative 3. There's one x left on top and one z left on the bottom. Okay, that's a shortcut we could have taken. Here we could have done 6x y times negative 2x y z, and then kind of counted everything up. 6 times negative 2 is negative 12. We have 3 x's, 2 y's, and 1 z. So that's longhand right there. Let me check my time and we're running short again. Have a lot to talk about with this lesson, which is why we'll be spending more than one day on it. Okay, I think I have one last thing to look at here. We can also expand with these, and I'm going to do these real quick because I have to get going. But remember, when we expand, this term is being multiplied both the terms on the inside. So really we have 3x times 2x and 3x times 4 with a minus sign here. So 3 times 2 is a 6, and x times x is an x to the second. X to the first, x to the first, we add our exponents together. Then we got a minus there. 3x times 4. Well, 3 times 4 is 12, and we also have an x there. So that would be the expanded version of letter A. And the only difference between A and B is that we have a negative 3x on the outside as opposed to just a positive one. So we have this and this. Alright, so we have 3x times 2x, or negative 3x times 2x. Negative 3 times 2 is a negative 6x squared. But now when we want to look at this, we actually have a negative times a negative. If we change this to plus minus 4, that's what we did when we were adding integers before. We can always change things to addition, remember, if we change the next number to its opposite. So we really have negative 3x times negative 4. Negative 3 times negative 4 results in a positive 12, and we have an x left over. So you can see how the sign switched here. On that one we have negative 6x squared plus 12x. Alright, I believe that's all I have for today. Shouldn't say that's all I have. It definitely took quite a bit of time. But we will be spending a lot of time on this. Thank you.